Okay, IB students, this video is going to go a little bit faster than a normal class because I'm not teaching class at the moment, so please make a habit of pausing when you need to do some work. For the warm-up, you should try those problems and then you should check back and see how you did. All right, so to show that a sequence is geometric, you need to show that you have a common ratio. So you need to show that you're multiplying by the same number r each time. You can show that by working backwards and dividing the terms. So 48 divided by 12, that should give you the same thing as 192 divided by 48. And that value will be your R value, and it is 4. So because you have a common ratio, you are showing that this is geometric. All right, to find u sub n, we're going to use your formula for geometric, which is u sub n equals u sub 0 times r to the n minus 1. Okay, so we need to find u sub 9, the ninth term. So that would be u sub 9 is equal to the first term, 12. Oh wait, the first term is actually 3. I forgot this was here too. Let's start that over. It's going to equal to 3. And then we're multiplying by 4 each time. And that 4 is going to be raised to an exponent. The exponent is going to be 8, and we get that 8 by taking n, which is 9, and subtracting 1. So you can put this all into your calculator at once. It's pretty simple. So I put in 3 times 4 to get my exponent. I'll go to the caret, and I'm just going to put in the 8 there. If I wanted to put the 9 minus 1, I might have had to put parentheses, depending on how old your calculator is. All right, and so this is my exact answer. If I wanted to round it to 3 sig figs, then this 6 here would round up 197,000. So exact and 3 sig figs. In today's notes, we're going to be talking a lot about money, and money is not rounded to 3 sig figs. US dollars will be rounded to the nearest cent. And many other currencies will be rounded the same way. We'll get to one that does not differentiate into cents. Okay. So the value of compound interest investment after n time periods is given by this formula. And this formula makes so much sense because we have, here's your end amount, and it's going to equal your starting amount times your interest. And it's going to be times your interest, the total number of times you apply that interest. So here's your starting amount. Your interest, say for example, if it's 5%, then it's going to be multiplied by 105%, which is 1.05, and you multiply by that 1.05 every time you apply the interest, and you apply the interest n times. So u sub o is your initial investment, and I is the interest rate per compounding period, and that is going to be as a decimal. So let's identify the components here. $5,000 is invested for 4 years at 7% interest compounded annually. That's 1 time per year. All right, what will be the amount at the end of this period? So u sub o is your starting amount, $5,000. And I is your interest rate. 7% as a decimal is 0.07. And n is the number of compounding periods. So 4 years, once a year, that will be 4 compounding periods. So u sub 4, the amount of money after 4 years, is going to equal $5,000 times 1 plus 0.07 raised to the 4th power. Now, some of you in your head can add 1 plus 0.07 to make 1.07, and you can write it that way. You don't have to write this step with a plus, if that makes more sense to you. And that's easier to put in the calculator as well. Okay. So that's going to give us $6,553.98, and you're going to round it to the cents there. Make sure your final answer has the dollar sign on it, $6,553.98. All right, so to find out how much interest is earned, the interest is what has been added to your money. So you started with 5,000, and this is what you ended with. So to find out how much is added, you just subtract. And in IB, it's really important that you show your step, even if it seems obvious to you. So you need to show how you got your answer. And then make sure you put a dollar sign on your final answer there. $1,553.98 in interest. Not bad. All right, we're going to do British pounds. 5,000 pounds is invested for 4 years at 3% interest compounded quarterly. So that means 4 times a year. Find the value of the investment at the end of this period. So we're still starting with 5,000, although it's 5,000 pounds, not dollars. And our interest rate is 3%, but we apply that 3% 4 times, and we don't apply 3% 4 times. That would give you a lot more interest than if you applied it 1 time. So you need to divide your 3% by the 4 to see how much of the interest is applied each quarter. And you should get 0.0075. Okay, and then the number of times it's compounded, well, for 4 years, but each of the 4 years is compounded 4 times. So that'll be 4 times 4. So n is 16 times that the interest is compounded. So to find u sub 16 time periods, still 4 years, you're going to take your start, 5,000, multiply it by 1 plus 0.0075 raised to the 16. And again, you can make this 1.0075 in your very first step if you want to. Okay, so go ahead and enter that in your calculator. And make sure you put your unit here. And then I got 5,634.96. So this is a good point for you to pause the video and try problems 3 and 4 on your own. All right, coming back from that, Gemma invested $4,000 in an account for 5 years at 4.8% interest compounded half yearly, so 2 times per year. Inflation over the period averaged 3% per year. So your U sub O is 4,000. Your interest as a decimal is, let's see, 4.8%. So this is the inflation. Don't confuse the inflation with the interest. Your interest is 4.8%, so 0.048. But we need to divide that by the twice a year. So it's going to be 0.024. And then the number of times it's compounded, 2 times a year, times 5 years. So the interest is compounded 10 times. Going to your formula, U sub 10 is going to equal your starting amount. And you can write 1 plus 0.024 or just write 1.024 raised to the 10th power. So pause the video and put that in your calculator. Remember to put your unit, and I get $5,070.60 when I round to that. Now, to find the real value of the investment by indexing it for inflation, we're just using the idea that the value of your money is affected by inflation, and the real value of your money times the inflation is going to equal the end value of your money. So the real value of your money times the inflation, 3%, so 1 plus 0.03, and that happens once a year for 5 years, so 5 times, is going to be your end amount of money, which is this. Okay, so to find that real value, undo your multiplication here by dividing. I'm going to divide both sides by 1.03 to the 5th. All right, that will cancel, and then let's see. Just remember though to put the dollar sign there before we even start. All right, let's see what this looks like in the calculator. Okay, so I entered and I should get the real value, which is $4,373.94. Okay, again, you should try problem 4 before watching. Notice that it's a little bit different because we're talking about depreciation, so that's a value that's going down. Dishwasher was purchased for 2,400 pounds. It depreciated by 15% per year, and we're trying to find its value after 6 years. So we know the starting value is 2,400. And the interest, because it's going down, is going to be negative 0.15. And this happens each year, so just one time a year. And then N is going to be 6 years. So U sub 6 is going to equal my starting amount. Now you can have 1 plus negative 0.15 to the 6, which is going to be your starting amount, times 0.85 to the 6. So pause the video and put that in your calculator. All right, and then remember your unit. So that's my unit, and 905.16 is what I get. By how much did it depreciate? That might seem obvious to you, but you do need to show the step. So the starting value is this, the ending value is this. So how much did it depreciate by? Let's put your unit on there. And 1,494.84. All right, so these problems can be done using the simple formulas, can also be done with technology. And the problems that we're going to do next, we're going to show you how to do them on the calculator, but they could be done the other way as well. Some of them just get a little bit complicated. So when we're using the solver, you're going to get a screen like this, and you're going to want to know what these variables are. So N is the number of compounding periods, just like before. I is going to be the interest rate per year. So per year, not per compounding period, so we don't divide it. Also, it is written as a percent, so it's not a decimal. PV is the present value or the starting value. And payment is a payment made each time period. So we haven't done problems yet with a payment. FV is the future value of the investment. And P/Y is the number of payments each year. And CY is the number of times interest is compounded each year. So those will be useful as we get to the solver. Now the directions for the solver are right here. We're going to go to Apps, Finance, and TVM Solver. Okay? And then another thing that's going to be helpful to remember is that once we get all of our numbers in, you scroll to missing value, so whatever we're trying to find, and then you're going to press alpha, and then you're going to press enter. Okay, so we're going to enter everything we know, then we'll scroll to the thing that's missing and press alpha and enter, and that will solve. Okay, so we'll need to keep these close by, but I'm going to move them off the screen so that you can see the problems. All right, let's look at this real quick. So let's go to Apps, Finance, TVM Solver. Okay, so you'll notice at the bottom here it says Payment End Begin. That lets you choose between payments at the end of a time period or at the beginning of a time period. But most of the payments, if we don't say differently, are going to be at the end of the time period. Let's see, when calculating, notice that the initial investment, that's the PV, present value, is entered as a negative value because that money is moving from you to the bank. The future value is the money you receive at the end, so future value is positive. N is the number of compounding periods, just like before, but I is the percentage interest rate per year, not per period. Okay, so the I is different. So let's write same for N, and we're going to write different for I. Okay, Sally invests $15,000 in an account that pays 4.25% interest compounded monthly. How much is her investment worth after 5 years? So N is the compounded periods, it's monthly times 5 years, so 12 times 5, that's going to give us 60. The interest rate is going to be written as a percent, and it's the interest rate per year, so 4.25. The present value is 15,000, but remember that we have to write it as a negative, so negative 15,000. This problem does not have us making payments. The future value is what we're trying to find out, and it's going to be 12 payments per year, 12. It doesn't really matter about how many payments per year since it's 0, but 12 compounding periods per year. Okay, so let's put that in here. So N is 60, I 4.25, present value negative 1,500. Payment, we're not making a payment. Future value, the solver needs you to put some number there, and we can just leave it as 0, and then we have 12 here, and we have 12 here, and we're going to leave this at end since the problem didn't tell us any different. Scroll back to the missing one, which is the future value, and press alpha and enter. All right, and it gives us the future value, which we are going to round to the cents. So we have $18,000, $18,544.53, because that 2 will round up. Okay. All right, so you should try the next one. Pause the video and give it a try. Okay, so Helena is investing money in a term paying 5.2% compounded quarterly. How much does she need to deposit now to collect $5,000 at the end of 3 years? So since it's quarterly, that's 4 times per year. So the number of compounding periods is 4 times the 3 years, so 12. Here's our interest rate. We don't know the starting value, the present value. Payment's still 0. future value would be 5,000. And because it's 4 compounding periods per year, we're putting 4 payments per year, even though they're 0. So when you put that in,